Yes, hello and welcome to this yWorks webinar. Today's webinar is going to be about automatic graph layout in our yFiles library. Thank you very much for joining in. I hope that everybody can hear me. First of all, let me introduce myself. My name is Armin Gufler, and I am one of the developers here at yWorks, part of the layout team, which develops and maintains the yFiles layout algorithms. So let's have a look at the agenda for today. For this webinar. First of all, I will give an introduction to what automatic layout means and to what automatic graph layout in yFiles is. The second and the main part will be about presenting the main layout styles, the main layout algorithms that our library offers. Then I'll talk about edge routing, which is a subtopic of automatic layout. And then I'll shortly also talk about label placement, which is also a subtopic. And finally, we will do a short Q&A, so question and answer session. If you have any question that arises during the webinar, please feel free to ask these questions in the chat here. I will not interrupt the presentation, but in the Q&A session, I'll try to answer all your questions. One final thing before we start off, I would like to mention is that we are also happy to receive feedback about what topics we could handle in future webinars. So especially for the layout topic that I'm going to introduce today, it's a very broad one, and we have a lot of settings, a lot of possibilities that could be discussed. And today will only be able to provide a rough overview and cannot go into details. So if you wish that we do maybe webinar about specific stuff, just please feel free to write it to us. Okay, well then let's start with an introduction to automatic layout. I'll try to define what automatic graph layout means. So an automatic layout algorithm, it places graph elements, and by graph elements we understand nodes, so the elements, the main elements, and then the edges which connect the nodes, and also labels that belong to nodes and edges. So a layout algorithm can place all these elements. At the same time, it obeys constraints given by the user. So things like that a certain node might need to be above another node, for example. And third, the algorithm optimizes aesthetic criteria. For example, it tries to avoid or minimize crossings between edges, or optimize some other criteria which are kind of specific to each layout style. The yFiles diagramming library offers, generally speaking, several kind of layout algorithms. The main layout algorithms are the ones that place all graph elements at the same time. So they place the nodes, they route the edges, and they may or may not also place the labels. Then the second type are routing algorithms, which only handle the roots of the edges, so they do not change the locations of the nodes. And finally, the label placement algorithms only handle node and edge labels, but they do not change the edges and node locations themselves. And we will discuss all these three types of algorithms during this webinar. But before presenting concrete layout styles, I would like to shortly show how easy it is to apply an automatic layout with the yFiles library. And that I'll show now. Here I have some very small and simple code snippets. Note that in these snippets, I refer to yFiles for HTML as the platform for the code, but the API of the other libraries, of the other yFiles libraries, is more or less identical, except some platform-specific conventions, of course. So I think this should not be a problem if you use another yFiles library. Generally speaking, we have several basic possibilities in yFiles to apply a layout. What I need to mention at first is that all the layout algorithms we have are of a type, or they implement an interface called iLayout algorithm. And the first version shown on the slide is this one, where you apply the layout directly on an instance of an iGraph. And you just call graph, apply layout, and you provide the instance of the layout algorithm. The second and probably most common way is to apply the layout on a graph component, which is the component that you show in your user interface, which holds the graph itself. And on the graph component, there is the convenience method called morph layout, where you provide a layout algorithm and you provide a time that indicates the duration of the morphing animation. So this is usually a really nice feature to see also an animation which indicates that nodes and edges are moved. Here on the slide, we see now an example how that looks like, just to illustrate what layout actually means. So we have a graph with, well, more or less random node positions and some edges connecting the nodes. And now if I start the layout like with the second code snippet, we see that this balloon layout style in this case was applied, and the nodes morph to new positions, and the graph ends up having a much nicer layout. And yeah, this is kind of just to illustrate what automatic layout means. And shortly, I have a third variant presented on the slide, which is a variation of the second, where you additionally also provide a layout data object. The data object kind of contains advanced configurations that affect the layout. I just wanted to shortly mention this here because it may be useful for you, but in this webinar, we will not go into details or detailed settings, which you can do with layout data. So this was meant to illustrate how easy it is to apply a layout and how that looks like. Now I'll like to add some general notes about automatic layout and about the terminology. So we say that layout assigns coordinates to graph elements, and it may rearrange the whole graph, or it may rearrange only parts of a graph. And it's really important that layout is distinguished from the visualization and view part of the yFiles library and of your yFiles application. So the layout, it is not style, it is not appearance of the elements, it doesn't care about the shape and color and stuff. The layout only consists of nodes that are rectangles and edges that are points. So this is really important, that if you apply a layout, the algorithm itself, it is not aware of your actual colors or of other styling things that are only part of the visualization. Okay, now let's come to the main part of this webinar, where I will present our most important layout styles. And I'll start off with the hierarchic layout. The hierarchic layout is probably our most, or is certainly our most versatile, and it's the most powerful algorithm we have, and it's also widely used in practice. The main characteristics are that nodes are distributed over so-called layers or levels, and the layout has a clear main orientation or direction. The layers can be seen in the sample layout on the slide. They are visualized as horizontal stripes. So in the first layer, you see there's only one element. The same holds for the second layer. Third layer, we have more elements. And you see that edges are pointing mostly in the same direction, in this case, top to bottom, so downwards. And of course, not all edges can point downwards if we have cycles in the diagram. So like on this part here, we have an edge that points in the opposite direction, which is necessary because if you have a cycle in your data, then not all edges can point in the same direction. So furthermore, the hierarchic layout places nodes, edges, and labels. So it can be responsible for all elements at the same time. And it offers also different routing styles for the edges. So in the first previous slide, you've seen edges that are orthogonal, which has only horizontal and vertical edge segments. And here in this example that's shown now, you see also diagonal styles. And you also see edge labels. So these edge 1, edge 2, and the backwards edge label at the bottom. And that means the layout algorithm also placed those at the edge. So placing the label means it nicely places it there, of course, while avoiding overlaps with other elements, which is the goal. So let's continue with another feature we have is group nodes and partition grid or table nodes. So the hierarchic layout is in this matter, it's the one algorithm that supports the most constraints. So on this sample, you see nested group nodes, which are no problem for the hierarchic layout. Doesn't matter how complicated the nesting is. And partition grid or table nodes are another feature not shown now, but it's kind of a table where you can organize and also separate elements by means of putting them into different rows or columns. This is a feature which is supported by other algorithms too, but I can say that the hierarchic layout is the one that has the best support for it. And so we usually recommend it if a grid is important for customers, or the same holds for group nodes with complex nesting structures and other constraints regarding group nodes. The hierarchic layout is the most powerful one here. So finally, for the hierarchic layout, let's look at the applications which are typical for this kind of layout. Typical domains are flowcharts or decision diagrams. It's used in process modeling, UML, activity diagrams. It's useful in a lot of software development use cases like visualizing call graphs. And while these are typical domains, one can also find a lot of general use cases where this style can be well suited. It's always well suited if the direction of information flow matters. So if all edges, for example, should point in that certain main direction. It's also suitable if complex constraints like port restrictions are necessary. A port restriction would be that you need to have the port on a specific site or location of a node. So the port, just to make that clear, is the point where an edge connects at a node. It is very well suited for large diagrams where you need orthogonal edges, because it's also quite fast and, for example, faster than the so-called orthogonal layout, which also produces orthogonal edge routes, but for large diagrams, it's slower. Another use case are use cases where you have from sketch mode. From sketch, we mean something like where you already have a good or almost good diagram and you want to add new elements, or you want to just refine it. So the hierarchic layout can also take the sketch that is given to it into consideration. And existing elements, they can keep their positions with respect to each other. So if an element was above a certain other element, it remains above it at the end too. Regarding some limitations of the hierarchic layout, generally there are no obvious limitations like the type of graph, but of course there are requirements where this style is not very suitable. For example, if it is important to nicely highlight symmetries in the graph, it may be that there are better options. Symmetries can be visible, but it is not a criteria that the algorithm explicitly optimizes. And while the performance is very good, it can well be that it is even fast enough for very large diagrams, but it can be said that the result in those cases may not be very useful. So especially due to complex edge routing, the picture may in the end just be a large blob of roots and bends, and so there is not much information for very large graphs. But yeah, for both limitations I mentioned here, so very large graphs and symmetries, there is another algorithm which is specifically suitable, and that is the organic layout, which I'm going to present next. Okay, the organic layout. Here we see a sample of the organic layout, and we see immediately that the kind of layout that it produces is extremely different. So in literature or other libraries, it is also known as force-directed layout. And the general idea of this organic layout is that it produces a natural distribution of the nodes, and it exhibits clusters and symmetric properties. So shortly put, the nodes are connected via some kind of physical forces, and the layout tries to produce a stable result where forces are low and the stress of nodes is low, so that symmetries in the end are nicely shown. This, of course, here is an example on a slide where the graph has a highly symmetric structures which are nicely exhibited when laid out with the organic layout. More features, the organic layout places nodes close to their adjacent or neighbor nodes. And another obvious feature that can be seen in the samples is that this layout has only straight line, simple edges, so no complex routings with bends. So it really places the nodes near the neighbors, and the connections, the edges, are just simple straight lines. It has also features to explicitly highlight certain substructures in a graph. This can be seen in the sample now. We see, for example, on top, and this I show it here, and this top component is a kind of it's a star. So you have one root and a lot of children connected to the same root. And such a star structure, for example, can be explicitly laid out in a certain way. And also other structures which are chains, for example, or circles, also visible in the sample, are laid out by a specific style. And this organic layout is very suitable for large graphs, also very large graphs. So typical applications of the organic layout. I already said that it's suitable for large networks or large graphs in general. So often things like social networks are good use cases for it, or a lot of applications from the bioinformatics are use cases that are suitable for the organic layout. On the right hand side of this slide, you see an example of a social network analysis graph. And generally, for general use case, it can be said, yeah, networks, all kind of networks where you only require straight edges. There you can use the organic layout. And also a general indication for organic layout would be if you have few placement constraints, if you don't need a specific directions for your connection, if you do not have leveling or layering like described for the hierarchic layout, if you don't have such constraints, the organic layout may be a good fit. Some limitations of the organic layout: it cannot place labels in an integrated style. Integrated means that the layout already makes space for the labels to place them. So this is not supported by the organic layout, and it has no different routing styles. So if you require a certain kind of routing, which is different from straight edges, then it's maybe a limitation in this case. Okay, that's it for the organic layout. Next, I would like to introduce another main layout style, which are the tree layouts. And for the tree layouts, we have the scenario that we do not consider a single algorithm, but we have a kind of a family of algorithms in yFiles that are specifically designed for the so-called tree graphs. So, as already said, tree layout algorithms are designed for tree graphs, and a tree is a graph where you have no cycles, and a tree has a global root node. So you have a root node, and the root node has child nodes, and the children can again have children themselves, and so on. So yeah, a tree, a hierarchy, kind of. The tree layouts nicely emphasize this relationship between the parent and child nodes in a diagram. For example, in the sample shown on the slide now, you see that child nodes are placed on a circle around their parent. So the relationship between parent and child nodes is always kind of nicely emphasized by tree layouts. Another important feature of tree layouts is that they support the placement of labels, like the hierarchic layout does too, as I mentioned earlier. And the organic layout presented before does not support that. So another important thing about tree layout is the tree layout in yFiles supports individual node placement strategies for each subtree. That means that each subtree that has its own local root can have another kind of placement strategy. This is illustrated on the current slide now. So for example, here you see different placement style. The whole layout doesn't look so great now, but it's just to illustrate different styles. So for example, here you see these children, all children of that node, they are kind of placed below each other in a certain style. And for example, here you have a root where the children are placed in a bus-like style, same as here. And here they are placed in a kind of a grid right of their root node. So the thing I want to say is that with the tree layout in yFiles, you can individually define how certain children are placed with respect to their common parent node. And this is a very powerful feature if you require that a certain parts of the diagram need to have another style than other parts of the diagram. This individual placement strategy is a feature which is belongs to the algorithm that's called tree layout in our API. So first point here on this slide, you see that we have more layout algorithms. Another tree layout algorithm is the balloon layout, which does not support this individual configuration. The balloon layout was this first example that I have shown. Let me go back. This is the balloon layout here again. For this balloon layout, you do not have the different styles for each subnode, but you have it for this so-called tree layout. Okay, let's look at applications for tree layouts in general. A typical application would be if you have a kind of network management software, for example, or if you have things like in business administration, for example, an organization chart. On this slide, you also see an example how an organization chart could look like. So you have the different employees and so on, and this layout shown here is actually produced by our tree layout with a specific configuration that tries to produce compact and nicely packed results. General use case, yeah, the obvious one is that it's suitable if your diagram, your graph is a tree structure, or almost a tree. It's really useful also if you need different styles for different parts of your diagram. This is because it supports this different placement styles that I presented on the slide before. For the limitations of the tree layout, of course, the obvious limitation is that it's not well suited for non-tree graphs. It actually can be applied to them, but they need to add another helper stage. And then what it does is that the edges which are kind of violating the tree structure, it needs to remove some edges to again have a tree. It applies this layout, and these special non-tree edges need to be handled by a routing algorithm, so the whole result is not so nice anymore if you have a lot of those non-tree edges. Another limitation is that it supports a lot less constraints than, for example, the hierarchic layout. So that's it for the tree layout. And that's already it for this main part, or the main three important layout algorithms that I wanted to present today. We have a lot more layouts which are specific for other use cases. The three main layout styles that I offered, they may be, or they are probably the most important ones, but we offer many more possibilities. But the time for this webinar is by far too short to discuss all available options. If you are interested in trying out other styles and also trying out the shown styles themselves, you can do that free and online via using our freely available graph editor via Live, for example. You see the URL here on the slide. You can also try out our layouts with the live demo, also available on our website, the layout styles live demo. Especially that demo shows all kind of layouts we offer, and it shows a lot of settings which you can yourself try out and play around or how they affect the layout. For this webinar, I will now only I would like to mention really shortly a few other styles, but then I'll go on to other topics, which are the edge routing and the label placement. Some other layout styles that I like to shortly mention and are presented on this slide. The first is the orthogonal layout. It's a layout that only produces horizontal and vertical edge segments, so therefore it's called orthogonal. And it does not have a hierarchy structure or something like the hierarchic layout, but if you have no direction or flow, it may be highly suitable if you have the requirement to produce orthogonal edges. In the middle, you see the radial layout, which can also be suitable for displaying hierarchies if you want to display them in a kind of a radial way. And finally, the circular layout is a layout algorithm that's placing the elements on circles, so on a common circle, and the nodes are placed on that circle, and the edges are routed between them. In the middle, they can be straight line, or like in this shown sample, they are bundled with nice curves. This kind of use case or this kind of diagram may be interesting if you have a lot of edges between rather few nodes and you want to place them on a common circle. And yeah, as I already said, this is not a complete list now of styles we offer, but there are more styles. And yFiles library also offers domain-specific layout algorithms. So domain-specific means algorithms that are specifically designed for a certain use case, for a specific domain, like the BPMN, process modeling notation, and so they produce specifically good results if you have that specific use case. All the other layouts are kind of, they have their good use cases, but they are held really general, so you can use them for all kind of graphs. Okay, now next, the next topic I am going to show is the edge routing. So far we have looked at automatic layouts that place nodes and root edges, and they may also place labels all at once. A very important subtopic of the automatic layout topic is the edge routing, and in the following I'd like to present the possibilities one has with yFiles regarding edge routing. So what does edge routing mean? It means an algorithm that only routes the paths of the edges and it does not change the node positions. On this slide, I have a short animation that illustrates this. So let me start it. So you have seen, go back again, you have edges without any roots, and if you apply the algorithm, it produces routings for these edges, trying to avoid, of course, overlaps with other nodes, trying to avoid crossings with other edges, and so on. So the nodes remain at their positions, but the edges are rearranged. What are applications for edge routing? In one application, maybe if you have manually placed your nodes, or your users place their nodes somewhere, but then the edges need to get a route to avoid that they are going through in the middle of overall elements. So you can just route them with the routing algorithm without changing nodes. Another application is if you want to reroute specific edges. For example, if you have a already good layout, everything is fine, but you insert a new edge, then not the whole layout should be changed, but only this edge might need to get a route. So you can say to the algorithm that it should only handle this single edge and route it. So next, I'll shortly provide an overview over the routing algorithms that yFiles offers. Our most powerful routing algorithm is the so-called edge router. It offers 3 different routing styles. So it has an orthogonal, octilinear, and curved style. On the right-hand side of the slide, you see the same diagram routed with edge router. The first example is having the orthogonal routing style. and the second shows the curved routing style. Another big important feature of the edge router is that it also supports buses, like shown in the sample now. So you have some common backbone bus segment where all other segments connect and branch off. And this kind of style is also directly supported by the edge router. Then another algorithm with a similar name, that's totally different algorithm, is the so-called channel edge router. So the difference, there are a lot of differences, but shortly put, it also creates orthogonal routes, but only orthogonal routes. It cannot create octilinear or curved routes. And the orthogonal routes are much simpler. So it does not have a really complicated algorithm searching for the path, but it's quite simple. But the really interesting advantage is that it's really, really fast. So the routes may be really simple, but if you have a really large graph and the quality of a single route is not that important, then this might be a good fit for your use case. And it does not support things like bus routing and other more involved features that are supported by the edge router. Finally, we have the organic edge router, which is totally different. It kind of produces routes that follow an organic, kind of a little bit curved pattern. You see one example here on the slide now. You see that edges are routed around the obstacle, so they are routed around other nodes to avoid an overlap, but the routes are kind of straight and a little bit of curves. So maybe this example here, it's not the most suitable style, but for other kind of algorithms where you, for example, had the organic layout as a main layout algorithm, this style, this edge routing algorithm might be interesting for you. So to wrap up the edge routing topic, I'd like to say that here I now really only provided a really rough overview, especially with respect to the edge router. We could present a lot of features. It really has a lot of things it can do. It can support a lot of different constraints, but this webinar is just too short to go into details here. And so that said, I'd like to come to the last kind of section that I'm going to present today. This last topic is label placement. Label placement means the automatic placement of node and edge labels. So a label in a graph always belongs to another element, for example, the node, and then we say that the node owns the label. And the label is a description, of course, some text for this element, and a node may also have many labels. The same holds for an edge. Here in yFiles, it's really important to distinguish two concepts, which are the integrated labeling on one side and the generic labeling on the other side. The integrated labeling, it's a labeling feature offered by main layout algorithms. So like, for example, the hierarchic layout algorithm that I presented earlier. If an algorithm supports integrated labeling, you can enable that via a property. And that means that labels are placed by that algorithms, while the other elements, the nodes and the edges, are placed too. And the big advantage is that the algorithm can already see the labels and it can make enough space for the labels to avoid any overlaps. Then the second concept we have is the generic labeling. The generic labeling is an algorithm itself that places labels only. So the generic labeling does not change other elements, and it only places the labels. It gets the layout as it is. And that's very useful, for example, if the main layout style or some custom style that you have or manually placed nodes, if that main style you have no integrated labeling, then you can use the generic labeling as a post-processing to distribute your labels. So that has the disadvantage that, of course, it might be that the elements are arranged in such a way that it cannot find a position without overlaps, so it cannot move away other nodes to make space. Finally, I would like to make one note, and that's regarding the so-called label consideration feature, which you find on a lot of our algorithms. So for example, the organic layout algorithm has the consider node labels property. The consideration feature means that labels are considered such that overlaps with them are avoided, but the labels are not actively placed. So they are not placed in a nice new position. They are just they're just considered to avoid overlaps. This needs to be distinguished from the integrated labeling feature. So shortly, some overview on the generic labeling algorithm that the yFiles API offers. As already said, it places node and edge labels. You can also select which labels it places. It might place only single labels. Node and edges are not changed. The goal is kind of to place the label close to the owner and avoid overlaps with other elements. And the algorithm allows different optimization criteria, and it allows to provide preferences for certain label positions. So to say via the API that you prefer some kind of positions over others. And here we see an example on the slide where we have a graph that resembles a kind of a map. We have only nodes and labels that are describing the nodes. And this would be a use case if you have the labels and you want that the generic labeling places your node labels such that node labels do not overlap other node labels and they do not overlap other nodes. Here on this slide, I would like to present another, what I think is a really nice use case for generic labeling. We had a little project where we implemented metro map style layout. And here we had an algorithm that makes the metro map layout and it places the nodes on the edges, but it does not do anything with the labels. So as a post-processing, we just applied our generic labeling with some custom criteria, some custom settings, and the generic labeling produced the result that you see here. So you can see that in some parts of the diagram, there's not a lot of space, so it needs to kind of look for the best option, but it tries to avoid overlaps with all other elements, and it rather nicely distributes the labels near their owners. Yes, so that's it from me and for this webinar so far. I really hope that you have enjoyed the webinar and that I was able to present you something new and to show you what the core essence of yFiles automatic layout is. Now we will have a short Q&A session. So please do not hesitate to ask if you have any questions. Okay, let's see if we already have some questions here. One moment. Okay, we have one question regarding the next release. When will the next release be and what changes are expected in it? Okay, the 2020 releases of yFiles will start as usually with the yFiles for HTML version. And that's going to be in late April or early May, I think. And the C# and Java versions will follow in summer with the same features. Major features for the layout will be that we have the Bézier curved edge routing that I already kind of mentioned for the edge routing algorithm. We have integrated. We have exterior edge routing for the circular layout. So the circular layout I did not present in more detail here, but the circular layout got a new routing style. And we have brand new layouts that are able to make space for in an existing drawing. So it's a kind of a new type of layout algorithm that we have where you make space in a certain area in an existing drawing. More new features are that the analysis part will contain new centrality clustering algorithms, and it's also going to have a simple way to run algorithms on subgraphs. And for the non-layout part, okay, there just maybe some short thing. There will be support for isometric visualizations and support for working with large graph model more efficiently. Okay, I hope that answers your question. Another question we have is, do you have any plans to support Kotlin JS declarations? Let me see. There is we have a public GitHub that one of our customers created and maintains. You can search for yFiles minus Kotlin on GitHub. So yFiles minus Kotlin on GitHub, and it has some bindings of good quality. And that said, I like to say, yeah, we have this on our wish list to provide the bindings ourselves, but this won't be part of the upcoming release yet. So, more questions? Yes. There is one question, I'll read it. We have Python algorithms for graph analysis and generation. Can yFiles for HTML integrate in an interactive manner with Python via a web server? What objects get sent back and forth? Okay, good question. Python. What objects get sent back and forth? yFiles itself does not use a predefined serialization mechanism because usually algorithms run in memory, but we have samples available that show how to serialize and deserialize graph from and to a simple JSON, for example. So This could be used to connect any third-party system. So it doesn't matter what third-party system. And of course, you can also create your own serialization format. And yeah, here I think the yFiles API should not be a limiting factor. So next question that we have, one moment. Can group nodes have their own layout? Yes, group nodes, there are several approaches available where you can have different layout for the nodes inside each group node. So we have one approach that's a recursive approach, which works with all layout styles, and there is also special support for a related use case available in the hierarchic layout algorithm, where substructures in a graph can be assigned a different layout strategy. So again, there is one really general approach, which is called recursive group layout. So for that recursive group layout, you can define an individual layout algorithm for each group, and the content of that group is going to be arranged by the specified algorithm. And the second thing I mentioned is that the hierarchic layout that I presented during this webinar as the first main style, it also has a feature where you can say that a certain substructure, so a set of nodes, is arranged by some other layout strategy. I hope that this answer is helpful for you. So let's see if we have more questions. One final question is, are there any differences between the yFiles products regarding the layout algorithms? That's a simple one, and the answer is there are no differences. So all the up-to-date yFiles products offer the same layout algorithms with the same feature set. Doesn't matter if you have the current yFiles for HTML or yFiles for WPF or yFiles for Java version. So the yFiles layout algorithm features are all the same if you are on the newest up-to-date version. Okay, let's see if we have one more. We have one more question regarding tree layouts. Sorry, again, the question is, the tree layout is for tree graphs, and thus it is also suitable for simple hierarchies, yes. But how does it compare to the hierarchic layout? Okay, so comparison, hierarchic layout and tree layout. Well, it's correct that they are both suitable for tree graphs. And whether the hierarchic or the tree layout is better depends highly on your specific use case. The tree layout has the advantage if different styles for a different part of your diagram are important. So for example, you need different orientations for a set of children. And the tree layout is a much more specific layout, which really offers a good quality for tree graphs, while the hierarchic layout is much more generic. And the advantage of the hierarchic is simply that it has it has more involved features. It supports more complex constraints. The edge routing is more powerful. It has more options for the edge routing. The group nodes are also a thing which where the hierarchic layout is more powerful. Yeah, I think just offers more features, but a general answer can also be that you are not sure if you want to use this or that algorithm. Maybe just the best idea to test both in our freely available graph editors with your kind of graphs and see which style is better for you. So, okay, we have one more question still. And the question is, what about web components? Is there plans to provide graph component as web component? Okay, I'm no expert in this, but let me try. So we actually had web components working in earlier versions of yFiles, and this was created as a demo where every developer should be able to wrap our component in a web component, I think, yes. And however, web components, they don't work with SVG due to a specification bug, actually. And thus, yeah, I'd say that we currently cannot recommend their use. Okay, so I hope that you could make something with that answer. I would like to say that I'm not the expert on this matter, unfortunately. Okay, I think we have no more questions. So, well then, I'd like to end this webinar. I hope that it was interesting for you. Thanks again for joining in. And if you have any more questions, do not hesitate to write us an email, support@yworks.com. Just drop an email if I forgot a question that you posted in the chat now. Just again, write us an email, or if you have other questions, or if you did not understand my answer or some other things in this webinar. Okay, thank you very much and goodbye.